Published by http://www.ijert.org International Journal of Engineering Research and Technology, IJERT, ISSN, 2278-0181 Volume 10 Issue 06, June 2021 A study on effectiveness of blockchain technology into construction supply chain management Bihari Abinaya Department of Civil Engineering, Thiagarajar College of Engineering, Madurai, India Dr. D. Srividya Lecturer, Otago Polytechnic Auckland International Campus, New Zealand Dr. G. Chitra Department of Civil Engineering, Thiagarajar College of Engineering, Madurai, India Abstract In this present environment, the supply chain in the construction industry is facing many constraints like lack of coordination, communication, collaboration, and technology upgradation, transparency, poor planning, and control. Supply chain management is very crucial while the products from one organization to another until it reaches the users or consumers without any damages, counterfeit, delay, etc. Consequently, the challenging issues in supply chain management were distinguished by reviewing numerous works of literature. Empirical data models for the study were done through semi-structured discussions with experts. The target people of the study were essentially focused on the contractors, subcontractors, and suppliers who were involved in construction projects. The separate proposals for contractors and suppliers were developed. The data grasped through discussions and distinguished from works of literature were examined by descriptive statistics with the aid of Microsoft Excels. This paper outlines the issues in supply chain management, notably payment-related concerns in the construction industry and also the usage of smart contracts by blockchain technology in the supply chain. Also, the lack of data management in transactions leads to complications and for determining the reason for the disputes, so blockchain technology is proficient in solving the issues addressed in the supply chain. Keywords: blockchain technology, late payment, smart contract, supply chain management. Introduction. A general supply chain management has been argued to increase productivity, reduce time, increase cash flow efficiency and minimize risk. 10 And also whenever the client requests a quality product and for more reliable services, the adoption of changes should be easy. A supply chain, SC, can be defined as a network of members linked together by the flow of materials, information, and funds to reduce overall system cost. 4. The supply chain structure depends on the intermediaries and the participants in construction projects. In general, the facilities in the supply chain are supplier, manufacturer, distributor, wholesaler, and retailer. Modern firms operate in a rapidly changing complex environment. 8 And increasingly depend on complex networks of supply chain partners to deliver goods and services in the accurate quantity at the right time and place under persistent cost and quality. SCM method was applied in different areas, particularly in the manufacturing area, logistics, and many others. It has effectively helped several ventures to increase profits and from the several years in international markets. The successful SCM applications of Walmart, P&G, Ford, and Dell are the main examples of this SCM. As a result, they have become the leading companies in the market. 4. When the members are not coordinated, it may lead to poor performance of the entire SC. Coordination among members can be achieved by an information sharing mechanism, and some of the objects in the sharing may include suppliers' capacity, customer demand, inventory policies, and inventory levels of other members. 4. Many factors are leading to a project's success, especially concerning the payment system. Many shreds of evidence link project delay due to the inefficiency of the payment system. Payment default is considered a major problem in construction. 1. The recent developments in blockchain technology have led to the discovery of smart contracts as a creative method for the automated execution of contract conditions. A blockchain is a method of decentralized consensus that was proposed to record transactions across a peer-to-peer network of computers. Blockchain was originally introduced for Bitcoin, a decentralized digital currency, or also referred to as cryptocurrency, but then has evolved to other decentralized applications, such as smart contracts. A smart contract is a computerized protocol whose implementation is automated through an executable code that runs on the blockchain. Smart contracts have control over the physical or digital objects according to the agreed terms too. The smart contract payment method led to cost-effective and efficient possibilities for the security of payment. B. Concept of supply chain management. The supply chain has been defined as the network of organizations that are involved, through upstream and downstream linkages, in the different processes and activities that produce value in the form of products and services in the hands of the ultimate customer. 13. Fig 1 shows that information flow and the material flow of the supply chain in manufacturing site. The information flow started from the customers like by placing orders, scheduling etc. The information flow is from right to left where the material flow is from left to right. IJERT 10 is 060437 www.ijert.org 989. This work is licensed under a Creative Commons Attribution 4.0 International License. Published by http://www.ijert.org International Journal of Engineering Research and Technology, IJERT, ISSN, 2278-0181 Volume 10 Issue 06, June 2021 Supplier Evaluation and Reporting Purchase Requisition Request for Quotation Fig 1 Information and Material Flow of SC in Manufacturing 13C Flow Chart of Supply Chain in Construction Industry The General Flow Chart of Supply Chain in the Construction Industries 3. The Fig 2 shows the flow of work from one part of the construction phases to other phases, like owners to architects and consultants which give the design. Fig 2 Flowchart of SC in Construction Industry 3D Reason for payment issues Most of the suppliers and contractors encountering late payments. Since the Article 6 reveals that 24% of suppliers' invoices are paid late, 58% are due to long internal processes 57% are because the invoice was received late 25% are due to technology issues This remains rare for suppliers to credit or expenses for late payments. 76% possess neither proposal to compensate suppliers toward late payments. Consequently, to evade late payment each purchase-to-pay cycle and order-to-cash cycle to be addressed and function fitly for the betterment into finance. E-procure-to-pay The purchase-to-pay cycle is a process related to purchase which is part of account payable. Reference 7 defines the purchase-to-pay cycle as follows. The purchase-to-pay cycle is the trade cycle from the point of view of the company making a purchase. During the purchase-to-pay cycle, the company selects, receives, and pays for the materials or other inputs needed in order for it to produce its goods or services. Fig 3 shows the purchase-to-pay cycle steps involved in the process. Supplier payment Purchase-to-pay cycle Invoice processing Material receipt Supplier selection Issue purchase order Fig 3 Purchase-to-pay cycle F Order to cash Reference 7 defines accounts receivables as follows. Accounts receivables are created by a firm when it sells its outputs on credit. The order-to-cash cycle relates to a company's receivables. The order-to-cash cycle is the same cycle as the purchase-to-pay cycle, however, from a supplier's perspective. Reference 7 defines the order-to-cash cycle as follows. It begins when a quote is prepared for a customer and ends when payment has been received and reconciled with the appropriate invoice. Fig 4 shows the order-to-cash cycle steps involved in the process. Customer evaluation and reporting inquiry from customers, or request for quotation submissio and to customer payment collection order to cash cycle receive purchase order billing, or invoices shipping, or delivery of materials packing of material Fig 4 order to cash cycle issue a sales order G. What is blockchain technology? Fundamentally, a blockchain is a decentralized, distributed record, or ledger, of transactions in which the transactions are stored in a permanent and nearly inalterable way using cryptographic techniques. 9. Blockchain is an immutable, tamper-proof distributed ledger technology, DLT, which is utilized in a shared and synchronized environment where all the transactions are IJERT 10 is 060437 www.ijert.org 990. This work is licensed under a Creative Commons Attribution 4.0 International License. Published by http://www.ijert.org International Journal of Engineering Research and Technology, IJERT, ISSN, 2278-0181 Volume 10 Issue 06, June 2021 Validated by users and are traceable. It enables a decentralized environment where all the members of the network can interact securely without the need for a trusted authority. Hence it eliminates the need for a central entity by validating and storing all transactions through distributed consensus. Smart contract, which are automated computer programs that are triggered to transfer digital assets upon meeting certain trigger conditions, is the core technology used in the application of blockchain in the humanitarian aid field. Corruption is a major problem in many third world countries, with multiple middlemen such as NGOs, local governments, etc. Smart contracts can help eliminate corruption by providing faster and less costly transactions with high transparency. 11. Blockchain technology for supply chain functions. SCM is an enormous sector and is the main skeleton of every industry. However, traditional SC systems are not versatile and transparent enough to accommodate the growing needs and demands of the future, leading to huge overheads in terms of error handling, costs, administration and fraud management. 11. 2. Literature. Venugopal Reddy Bachelor, et.al., 2020, 3, paper, gives an overview of disparate factors which inhibit the involvement of supply chain management for the business development in the construction industry. The questionnaire survey was framed, including past studies, also with the experts. A face-to-face interview was also conducted. In this study, more than 10 organizations are considered. Collected data are analyzed by the RII method and ranking of factors are done based on the mean value of RII. The findings of the paper result that contractors should provide the solution for the improvement of supply chain management application in the construction industry. Joby George, et.al., 2018, 4. This paper identifies various factors affecting supply chain performances. A detailed study is done by reviewing various works of literature for identifying the factors. Considering 54 works of literature, the factors are identified. The major factors: inventory control policy, information sharing, consumer demand, lead time. The appropriate selection of parameters of these factors improves the supply chain performance. Pinpoint the association between supply chain integration, SI, and supply chain risk management, SCRM, to improve operational performance. The paper synthesizes the role played by supply chain risk management, SCRM, between supply chain integration, SI, and firms. Operational performance is examined. The data is analyzed based on covariance for the developed hypothesis. The paper gives a framework demonstrating the effects of supply chain integration, SI, on supply chain risk management, SCRM, and the performance outcomes to develop managerial implications. Omohala Samuel Oludari, et.al., 2018, 10. This paper states that supply chain management affects profitability and risk reductions. And as large number of participants involved in the delivery of projects is still complex. To address this, questionnaires were circulated to medium and large-sized firms. The data is analyzed using the Frequency Distribution and Relative Importance Index, RII. The finding shows that 42.6% of respondents rated lack of trust for suppliers which are discouraged by them. Muloki Rita, et.al., 2020, 11. This paper states the current practice of health supply chain. The study summarizes the benefits and challenges of blockchain technology. The paper focuses on healthcare supply chain with the application of blockchain technology in supply chain of healthcare. 3 research objectives to identify the challenges and issues in the existing supply chain management. To study the effectiveness of blockchain application for the supply chain issues in the organization. 4 research methodology. This paper aims to study the challenging issues in existing supply chain management in construction industries and to study the effectiveness of the application of blockchain technology into supply chain management. The data were collected through semi-structured interviews with experts. The data collected through interviews and identified from works of literature were validated and analyzed. The data will be instantiated in pie charts and bar charts. V results and discussions. The results from the interviews obtained from both suppliers and contractors are discussed below based on the objective of the study. Communication barriers. Christofik, et.al., 2012, 7. This paper focused on collaboration with other parties within the chain. The author aimed to find the differences in working capital management, WCM. In particular, collaboration and transfer of information between different departments managing each element of the supply chain is a key. 40%, 20%, supplier 1, supplier 2, supplier 3. Manal Munir, et.al., 2020, 8. This paper is focused on the information processing view of risk management and Fig 5 communication barriers experienced by suppliers. IJERT 10 is 060437 www.ijert.org 991. This work is licensed under a Creative Commons Attribution 4.0 International License. Published by http://www.ijert.org International Journal of Engineering Research and Technology, IJERT, ISSN, 2278-0181 Volume 10 Issue 06, June 2021 Fig 5 shows whether communication was a barrier for the suppliers. About 40% of communication barrier was experienced by the supplier 1 and supplier 3 and 20% is experienced by supplier 2. Material information Fig 8 shows the transportation issues experienced by the suppliers. About 40% of transportation issues was experienced by the supplier 1 followed by supplier 3 experienced 33% of transportation issues. The supplier 2 experienced 22% of transportation issues in the company. Selection of suppliers: Contractor 1, Contractor 2 27%, 33%, 40%, Supplier 1, Supplier 2, Supplier 3 20%, 20%, 20%, 20%, 15%, 18%, 16%, 15%, 10%, 5%. Percentage Fig 6 Material information specified by suppliers. Fig 6 shows whether material information are specified by the suppliers. About 40% of material information was specified by the supplier 2 followed by 33% of information was specified by supplier 1. The 27% of material information was specified by supplier 3. Payment issues: 50%, 40%, 30%, 20%, 10%, 0%. Supplier 1, Supplier 2, Supplier 3. Fig 7 Payment issues experienced by suppliers. Fig 7 shows the payment issues experienced by the suppliers. About 50% of payment issues were experienced by the supplier 1 and supplier 3. The supplier 2 experienced about 25% of payment issues in their company. Transportation issues: 33%, 45%, 22%. Supplier 1, Supplier 2, Supplier 3. Fig 8 Transportation issues experienced by suppliers. Fig 9 Selection of suppliers by contractors. Fig 9 shows the selection of suppliers by the contractors in the construction company. Based on service offered by the suppliers, about 20% were selected by both the contractors. About 20% and 15% were selected based on the quality of materials by the contractors respectively. Based on delivery, 18% was selected by contractor 1 and 20% was selected by contractor 2. Followed by providing specifications and requesting a formal quote from suppliers, about 10% and 5% were selected by the contractor 1 and contractor 2 respectively. Based on financial stability, 15% and 16% of suppliers were selected by the contractor 1 and contractor 2 respectively. Communication barrier: 66%, 64%, 62%, 60%, 58%, 56%. Contractor 1, Contractor 2. Fig 10 Communication barrier experienced by contractors. Fig 10 shows whether communication was a barrier for the contractors. About 60% of communication barrier was experienced by the contractor 1 followed by 65% of communication barrier was experienced by the contractor 2. IJERT 10 is 060437 www.ijert.org 992. This work is licensed under a Creative Commons Attribution 4.0 International License. Published by http://www.ijert.org International Journal of Engineering Research and Technology, IJERT, ISSN, 2278-0181 Volume 10 Issue 06, June 2021 Evaluation of suppliers: Contractor 1, Contractor 2 25%, 25%, 25%, 20%, 20%, 15%, 15%, 10%. Fig 11 Evaluation of suppliers by contractors. Fig 11 shows the evaluation of suppliers by the contractors. Based on timely delivery, 25% of suppliers were selected by both the contractors. Then based on order processing and invoicing system of the supplier, about 20% and 15% were selected by the contractor 1 and contractor 2 respectively. Based on categorization in specific area, about 10% and 15% were selected by the contractor 1 and contractor 2 respectively. Based on terms and conditions, about 20% of suppliers was selected by the contractor 1 followed by 25% of suppliers was selected by the contractor 2. Payment issues: 46%, 54%. Contractor 1, Contractor 2. Fig 12 Payment issues experienced by contractors. Fig 12 shows the payment issues experienced by the contractors. About 46% of payment issues was experienced by the contractor 1 and 54% of payment issues was experienced by the contractor 2. Willing to adopt blockchain 0%, 17%, 83% yes maybe no. Fig 13 willingness to adopt blockchain by suppliers and contractors. Fig 13 shows the suppliers and contractors' willingness for adopting blockchain technology for the betterment of supply chain management. A inference from the discussions with suppliers and contractors. It is inferred from discussions with suppliers and contractors that both of them undergoing communication issues because there is no proper management. More than 50% of suppliers encountering payment-related issues that influencing the bond with the buyers to have a prolonged relation. Contractors were choosing the suppliers based on service offered, quality of material distributed, and also on-time delivery without any delay. So, the problems identified like communication barrier, payment, and also transportation will provide advancement if blockchain technology were integrated into the supply chain. Mainly smart contract via blockchain contributes an improvement in payment associated issues. Blockchain technology working concept also via smart contract and its benefits and challenges were addressed below. Supply chain management of construction industries may improve by updating into new technology such as blockchain technology for better management. As blockchain have better visibility, trustworthy, unalterable, transparency and also enabling enhanced data sharing. B. Blockchain technology in the simplest terms, a blockchain consists of a linked chain that stores auditable data in units called blocks. Each block contains data, anything of value, its own hash value, a unique cryptographic value containing characters and numbers generated through a complex computational algorithm, and a pointer to the hash of the previous block 12. Figure 14 shows a blockchain developed after the transaction. Fig 14a blockchain IJERT 10 is 060437 www.ijert.org 993. This work is licensed under a Creative Commons Attribution 4.0 International License. Published by http://www.ijert.org International Journal of Engineering Research and Technology, IJERT, ISSN, 2278-0181 Volume 10 Issue 06, June 2021. C. Types of blockchain. 3 major types of blockchain networks, each having their own characteristics are consortium blockchain, private blockchain and public blockchain. 12. Consortium. A consortium formed by a group of members control this blockchain. Verifying and adding records to the blockchain is based on a consensus mechanism by a pre-selected set of nodes. Example, in regulatory-related decision-making. Private, this is controlled by a centralized entity. Only people with specific authentication and permission can be part of this network and thereby can verify and add records to the blockchain. However, the blockchain could be publicly viewable. Participants in this blockchain know and trust each other. Also known as a permissioned ledger. Example, a permissioned ledger between banks to settle interbank fund transfers and supply chain with well-defined roles for all actors. Public or permissionless blockchain are decentralized and are visible to the public. Anyone can join or leave the blockchain and anyone can verify and append transactions to the blockchain. This type of blockchain facilitates the dynamic collection of participants who may not know each other. Hence, stringent consensus mechanisms have to be implemented in the system. Examples, time stamping, trading of renewable energy. D. How it works. Fig 15 shows how the blockchain technology works when a transaction is requested. 5. Substantial time capturing of every piece of information had been performed. Customized and unique contracts can be determined toward all duties, moreover can be organized by each other. Betters visibility and excludes the need for an intermediary. Helps follow the status of an object throughout a process. Automates data examination activities. End-to-end clearness based on trust level by authority. Develops end-to-end activity of the supply chain method. Recognizes flaws plus problems, in the commencement, to obtain the process robustly. Points to a continuous chain of transactions. Boosts speed. Gains trust with stakeholders of the process. Consensus mechanism toward every alteration. Assures assurance of each transaction. G. Challenges in implementation of blockchain in supply chain. Satisfying any stakeholders to share information remains a difficulty. Organizations' extensive technology transformation and selection were expensive, also time-consuming. Privacy and protection of data want to be assured as the technology is yet quite immature and helpless. Governing change can affect many undesired complexities. Blockchain should be employed selectively, later scaling in the finance of implementation in phases of both expense and uncertainty. Huge numbers of stakeholders were included, and altering age-old mindsets, knowledge, and practicing method were a prominent problem. Intermediators connected at different levels might be reduced, which can perform rifts. A thought that blockchain implementation might head to loss of careers. Fig 15 Blockchain Structure Overview 5e Smart Contracts. Smart contracts are self-executing agreements that are triggered on the basis of predefined and agreed events. The smart in a smart contract comes from the fact that the clauses in the contract are evaluated and the appropriate code executed without human intervention. Settlements in smart contracts are automatically triggered if the pre-agreed conditions coded into the contract are met. Imagine something along the lines of the automatic debit used by merchants to take payment from your bank account, based on pre-agreed conditions, full payment, part payment, minimum amount, etc., on a pre-agreed day or date. 12. Benefits of blockchain in supply chain: authorizes calibration of data determined over distinct supply chains. Enhances protection of data saved. 6. Conclusion: the study investigates the challenging issues which inhibit the improvement of supply chain management. The objective of the study was to identify the challenging issues in the implementation of supply chain management and to study the application of blockchain technology for enhancing the supply chain management in the construction industry, especially for payment issues using the smart contract. We can understand that the supply chain affects profitability and project expectations in terms of cost, time, and quality, and risk reduction. The study provided new insights into the construction industry, how the blockchain will change existing concepts of supply chain management. The blockchain was introduced to achieve the supply chain objectives, by reducing the risk from tracking and data management and recording of transactions. Blockchain facilitates valid and significant measurement of outcomes and performance of key supply chain processes. The study explores how blockchain may IJERT 10 is 060437 www.ijert.org 994. This work is licensed under a Creative Commons Attribution 4.0 International License. Published by http://www.ijert.org International Journal of Engineering Research and Technology, IJERT, ISSN, 2278-0181 Volume 10 Issue 06, June 2021 Transform the Supply Chain in the Future. Overall, blockchain technology as an application to supply chain management shows promise. References: 1. Abdul Hamid, Abdul Rahim, and Badruddin, Maud and Rahman, Syazwani and Zakaria, Razina and Mohans, Saeed Reza. 2016, Late Payment Practices in the Malaysian Construction Industry. Malaysian Journal of Civil Engineering, MJCE. 28 149-162. 2. Amadishik Mast, S., and Sanmay, R., 2020. A Smart Contract System for Security of Payment of Construction Contracts. Automation in Construction, 120, 103401. doi 10.1016/j.otkin.2020.10340113 Bachala, Venugopal, and Nambaru, Sandeep and Kohn, Venkatesh. 2020, a study on factors involved in implementation of supply chain management in construction industry. Materials today, Proceedings. 33 10.1016/j.matpair.2020.04.900. 4 George, Joby, and Pillai, Madhusudanan. 2019, A Study of Factors Affecting Supply Chain Performance. Journal of Physics, Conference Series. 1355-012018. 10.1088/17426596/1355/1/0120018. 5 https://www.pactpub.com/product/blockchain across Oracle/978178847429006 https://www.procurious.com/procurement news 7 Christofik, Peter, and Koch, Jenny and Vries, Cybran, and Hoff, Jenny. 2012, Financial Supply Chain Management Challenges and Obstacles. ACRN Journal of Entrepreneurship Perspectives. 132 to 143. 8 Munir, Manal, and Jaja, Muhammad Shakil Sadiq and Chitra, Cameron, and Farouk, Sami. 2020, Supply Chain Risk Management and Operational Performance, the Enabling Role of Supply Chain Integration. International Journal of Production Economics. 227 107667. 10.1016/j.ij.2020.107667. 9 Nick Allison, et.al., 2020, Applying Blockchain to Product Compliance and Assurance in the Construction Industry, ISSN, 2423-0839. 10 Olugboyega, Olasi, and Omohala, Samuel. 2018, Construction Supply Chain Management Systems in Lagos State, Nigeria. The Journal of Scientific and Engineering Research. 511. 11 Rita, Muloki, and Kanga, Dominique and Fatima, Taif, and Azuazi, Mohammed. 2020, Blockchain in Health Supply Chain Management, State-of-Art Challenges and Opportunities. Prostia Computer Science. 175 706 to 709. 10.1016/j.prox.2020.07.104. 12 Sylvester, et.al., 2018, E-Agriculture in Action, Blockchain for Agriculture Opportunities and Challenges, published by the Food and Agriculture Organization of the United Nations and the International Telecommunication Union. 13 Vrihov, Ruben, and Kaskila, Lori. 2000, The Four Roles of Supply Chain Management in Construction. European Journal of Purchasing and Supply Management. 6 169 to 178. 10.1016/S09697012, 000013-7. IJERT 10 is 060437 www.ijert.org 995. This work is licensed under a Creative Commons Attribution 4.0 International License.